All right, so I had a bunch of you talk to me about how you really enjoyed these. So we're gonna try this again and see how it goes in chatting about identities and see if this works for you guys. Okay, so to begin, we're gonna chat about what are called reciprocal identities. So reciprocal identities, if you think about it, the fraction 4/5, what's the reciprocal of that? Well, 5/4, you just flip the numerator and the denominator, right? So these on the right side, I feel like you already know these because we had to talk about them in chatting about cosecant, secant, cotangent, all of these things, right? So cosecant is just 1 over the sine of theta. Secant, 1 over cosine of theta. Cotangent, 1 over tangent. So these, I feel like, check, you already know these. On the flip side, I feel like it's common sense maybe, but you maybe haven't thought through it, that sine of theta is the same as 1 over cosecant. And you can get to that through a number of ways. You would know that if you just flip these two spots using, it's essentially cross multiplication, but if you just flip these two spots, they would be the same thing. So sine of theta equals 1 over cosecant, cosine is 1 over secant, tangent is 1 over cotangent. You could also think about it like, to me it's too complicated. The simple algebraic like thinking makes more sense, but you could also say this is 1 over sine theta. So this is the same thing as 1 times sine theta over 1, if that makes sense. So it ends up being sine. So I think that's way too complicated, an overcomplication of what's a simple algebraic understanding, but those are your basic reciprocal identities, okay? So from that, we can also build another reciprocal identity, which is that tangent theta is sine over cosine, which we already know, and cotangent is the reciprocal of that, cosine over sine. So the way you get that is thinking back to that X, Y, and R triangle that we kind of began all this stuff with a long time ago. And you remember tangent is opposite over adjacent, which is Y over X. And through all of our studying, we realized that sine is Y and cosine is X. So that's kind of where, I don't know that we ever actually talked about that, now that I'm thinking about where it came from. But tangent is sine over cosine. So same is true of cotangent if cotangent is the reciprocal of that. If tangent is opposite over adjacent, cotangent is adjacent over opposite, which is X over Y, which would be cosine over sine. So you can kind of see where all of these pieces come into play. Okay, one other piece that we need to discuss before we jump into the next category is talking about how these things also hold true for powers. So kind of weird to think about, but if you have sine squared, and that can be written either way, either of these things are true, they mean the same thing, it's that whole sine function squared. This is the same as 1 over cosecant squared, okay? So this is the same as 1 over cosecant squared. And this could be true if you had sine cubed of theta. This is the same as 1 over cosecant cubed of theta. So cubed fourth, and this works for every single function, every single reciprocal function, as long as those relationships are true. You can just essentially, if you go back to this, you can essentially cube this, put this to the 4th power, 5th power, does not matter what power you raise these things to, those properties hold true for the reciprocal functions.